The sun is not just the warm glow that lights our days, it is a restless, boiling star constantly throwing out streams of charged particles and sudden bursts of energy. To us on Earth, it feels distant and calm, but in reality, the sun is an engine of storms. These solar storms can disrupt satellites, damage power grids, and even endanger astronauts traveling beyond our planet. That is why NASA has recently launched a trio of missions to watch the sun more closely than ever before. Together, these missions, IMAP, the Carruthers Geocoronal Observatory, and SWFOL-1, are part of a global effort to understand space weather and protect both technology and human life. Space weather may sound like science fiction, but it is a very real challenge. When the sun releases a powerful flare or a burst of plasma called a coronal mass ejection, the effects race across the solar system at incredible speeds. If they collide with Earth's magnetic field, they can spark stunning auroras, but they can also cause serious problems. GPS signals can be knocked out, communication satellites can fail, airlines may have to change routes, and in the most extreme cases, entire electrical grids can collapse. As we prepare for a new age of space exploration, with astronauts heading back to the moon and eventually to Mars, the stakes are higher than ever. Understanding and predicting space weather is no longer optional, it is essential. The first mission in this trio is called IMAP, short for Interstellar Mapping and Acceleration Probe. Its job is to study the constant flow of charged particles streaming from the sun, known as the solar wind. These particles shape a vast protective bubble around our solar system called the heliosphere. By measuring the solar wind and the energetic particles that travel with it, IMAP will help scientists understand how radiation spreads through space. This knowledge is critical not only for protecting spacecraft and astronauts, but also for grasping how cosmic rays from beyond our solar system interact with the environment around Earth. The second mission is the Carruthers Geocoronal Observatory. The word geocorona may sound unusual, but it simply refers to the very outermost layer of Earth's atmosphere, where hydrogen gas extends far into space. This layer is almost invisible, yet it plays an important role in how Earth interacts with the sun's radiation. The Carruthers Observatory will watch this thin halo of hydrogen, tracking how solar activity influences it. By doing so, it will give scientists a better picture of how Earth's atmosphere responds to solar storms and how energy from the sun makes its way down into our planet's systems. The third mission is called SWFOL-1, which stands for Space Weather Follow-On at the L1 point. The L1 point is a location in space about 1 million miles from Earth, where the gravitational pull of Earth and the sun balance in just the right way. From this stable perch, SWFOL-1 will serve as an early warning system for solar storms. It will watch the sun in real time, detecting dangerous eruptions and sending alerts back to Earth so power companies, airlines, and satellite operators can prepare. This kind of warning could mean the difference between a short disruption and a major technological disaster. Taken together, these three missions are more than just scientific experiments. They are part of a shield for our civilization. We live in a world where technology connects everything: navigation, banking, air travel, even the lights in our homes. A single powerful solar storm could disrupt all of that. In fact, history has given us warnings. In 1859, a massive solar event known as the Carrington Event lit up the skies with auroras and disrupted telegraph systems across the world. If something like that happened today, the damage could reach into the trillions of dollars. By having eyes constantly on the sun, NASA and its partners are making sure we are not caught off guard. And this effort is not only about protecting Earth. As humanity prepares to step beyond our home planet, space weather becomes a direct threat to astronauts. On the way to the Moon or Mars, astronauts will be far outside Earth's protective magnetic shield. A sudden solar storm could bathe them in radiation strong enough to cause serious harm. By monitoring the sun, missions like IMAP, Carruthers, and SWFOL-1 provide the data needed to forecast such events, giving astronauts the chance to take shelter in protective areas of their spacecraft or bases. In this way, solar monitoring becomes not just a scientific pursuit, but a life-saving tool. These missions also symbolize something larger, the way humanity is beginning to treat space as part of our environment. Just as we monitor Earth's weather, track storms, and prepare for hurricanes, we are now learning to do the same with the sun. It is a shift in mindset. Space is not empty, it is dynamic and filled with forces that can shape our future. By investing in these missions, NASA is ensuring that we move into the next age of exploration with both curiosity and caution. In the end, keeping eyes on the sun is about balance. It is about embracing the awe of our star while respecting its power. The sun gives us light, warmth, and life itself, but it also has the strength to disrupt our modern world in an instant. Thanks to these new missions, we are closer than ever to predicting its moods, protecting our technology, and ensuring that the explorers who venture into deep space can do so with safety and confidence. The sun may be 93 million miles away, but its influence reaches into every part of our lives. Now, at last, we are watching it with the attention it has always deserved.